right, let's continue on with the binomial expansion by using Pascal's triangle for this next example. And you can see that this is a binomial, of course, with, you can call that row 7. If we did row 0, 1, 2, and so forth. This is where you're going to have to kind of know, where do I start off of the triangle? Do I want to rewrite the whole triangle? Not normally. This is why I like to memorize at least row 5. And remember that row 5 was 1, 5, 10, 10, 5, 1. Because that one's a pretty easy one to memorize. Row 6 would be a 1, and then these two numbers added together, which gives you 6, and then the 5 and the 10 added together gives you 15, then 20, then 15, 6, and 1. And then row 7 is the one I need. It's going to start with a 1. It's going to be 1 plus 6, which gives me 7. If you want to kind of do it between the space so you can kind of see the triangle being built, you can do it that way. And that's 21 here, 35 here, 35 here, 21, 7, and then 1. And you can space them out so it goes in between the spacing for each row, and you can kind of keep track so you don't miss a number. And if you notice, the odd rows have even amounts. Remember, it's always the exponent plus one more term. So that should be even. That means there's going to be a double in the middle that's exactly the same. If this is an even number, you're going to have a plus 1 of terms, so that makes 7. Over here, that means there's just going to be a single in the middle, and it kind of does like a mountain. Goes up, comes down. And then row 7 is going to be even again. And so the middle two should match, and they're mirror images on both sides. There's a lot of patterns you can look at. Well, let's look at doing this next item. So I'm going to take, and I'm going to go all the way over here, x plus 2 to the 7th. Sorry about that. And this item is your A. This one is your B. They're both monomial in itself. Sorry, this moved. Being that it's a binomial with just a singleton of an x and a singleton of a 2 in each position. So let's begin. I have my coefficients, and I go, okay, I have 1, and remember my A times x to the 7th, because it's always to the highest. And this is where you can decide, do I want to do them both at the same time, the A's and B's, or would I rather do A separate and then B separate? Maybe this time I'll do A and B separate. So I'll leave a little space. Plus 7 times my A to the 6, because it's going to go down, plus 21, my A is x, to the 5th, leave some space for your B, plus 35 x going down to the 4th, leave a little space, plus 35, and we have x to the 3rd, leave some space, plus, and then I'm going to go 21, x to the 2nd, space, plus 7, x to the 1st, leave space, plus 1. Remember, this is going to be x to the 0. Do I need that? No. If you want to put it, that's fine, just to keep track and make sure, and you can eyeball it, 7, 6, 5, 4, 3, 2, 1. Good. Now go back and do B. So this would be B to the 0. Well, that's just 1, but that's okay. Or excuse me, not B, but 2 to the 0. I really do wish I invented whiteout. That'd been awesome. But, so 2 to the 0, and then we have 2 to the 1, 2 to the 3, 2 to the 4, 2 to the 5, 2 to the 6, 2 to the 7, and oh, I forgot my 2. Shoot. And I was going to go back and check those. That's a 4, that's a 5, 6, and here's 7. See how I can catch that? At this point, I would have gone back anyways and go, okay, 7 plus 0 is 7, 7, 7. And I would have caught that I forgot my 2. And then 4 plus 3, 3 plus 4, and so forth and so on. We all make mistakes, but we can always work it out. Now, you can do it that way. You could do it the way I explained it in example 1, where you just go along and do it at the same time. It's up to you. But I always go back and double check, do those two numbers add to be the nth power that I have? Because I would have caught it, if not then, before I start doing all my math. Now we have to get that down and reduce it. So, as a reminder, anything to the 0, that's a 1. That means this one over here is also a 1. So 1 times 1 times x to the 7th. So I get 1x to the 7th. I do not need to show the 1 in front of it. Now I have 2, you have some constants over here. So I have 2 to the 1st, that's 2. 2 times 7 gives me a plus 14, and then I have the variable x to the 6th. Then over here, I'm going to have my constants can multiply together. So 2 squared is 4. 4 times 21 is 84, and that's x to the 5th. Then you got 2 cubed, which is 8. 8 times 35 will give us 280, and then my variables are going to be x to the 4th. And continue on, multiply that out, and here's the rest of it. 672 x to the 2nd plus 448x plus this last one is 2 to the 7th times 1 times 1. There are no variables. So I have a constant number of 128, and that's what this item equals. Notice that they are not going to look like the Pascal's triangle where it goes up and it comes down. It's all based on what the value of A and B are. So I hope that helps.